Ever feel like you're just scratching the surface when you use your computer? Like there's this whole hidden world kind of humming away behind your desktop.
Right?
Well, you're not wrong. Today, we're diving deep, deep into that world, the world of Windows internals.
Yeah.
We've got excerpts from Mark Rusinovich's Windows Internals Part 2. And this book, well, it's basically like the techie's Bible for understanding how Windows really works, you know?
It's like getting a backstage pass,
Yeah,
right?
yeah.
Like we get to peek behind the curtain and see all the nuts and bolts of what makes Windows tick.
Exactly. And I don't know about you, but I always find that, like, understanding how things work makes me feel more in control, you know?
Absolutely.
Yeah.
Especially with something as complex as an operating system.
Right. So where do we even begin? This book is massive.
Well, I think we need to start with the foundation,
Yeah.
right? Windows architecture. Have you ever wondered why, like, one single program crashing doesn't bring your entire computer to a grinding halt?
Honestly. Yeah. It's something I've just always taken for granted. Like, why doesn't my whole computer just freak out when one thing crashes?
Right. Well, it all comes down to how Windows is, like, designed at its core.
Yeah.
So imagine your computer is like a car.
Okay.
So the engine, which represents what we call kernel mode, that's the heart of the operation, directly controlling all the hardware.
Makes sense. So what's user mode in this analogy?
User mode, that's like the driver's seat. It's where all your applications run, like your web browser or your word processor. And get this, Windows actually keeps these two modes totally separate. The engine, the kernel mode, it's heavily guarded. No accidental tampering by the driver, by user mode.
Ah, okay.
So even if an application crashes in user mode in the driver's seat, it shouldn't take down the entire system. The car's still okay.
That's a really clever design. So Windows is kind of playing security guard, making sure that everything runs smoothly.
Precisely.
Yeah.
And this security extends to how Windows handles, drivers.
Yeah.
Those little bits of software that let your computer talk to your printer or your graphics card.
Drivers. Yeah, I've definitely had my fair share of frustrations with those, especially when they cause those dreaded blue screens, you know.
Absolutely. And the excerpt, it actually explains that there are different types of drivers. So some, like the ones for your printer, are plug and play. Windows automatically recognizes them, installs them, it's great. But others, they're more complex. They might require manual installation.
Okay, that makes sense. But what about when they misbehave? What's actually happening when we get a blue screen?
Well, think of it like this. A blue screen, basically a panic button, happens when a driver tries to access memory that it shouldn't, potentially putting the whole system at risk.
So Windows like slams on the brakes to prevent a major crash.
Exactly. Might seem dramatic, but it's a safety mechanism.
That's actually kind of reassuring. So it's not just a random act of computer cruelty.
Definitely not. And speaking of memory, that's another fascinating aspect of Windows internals. Think of memory as your computer's workspace. The more workspace it has, the more it can get done simultaneously.
Right. I've definitely noticed if I have like a ton of programs open, my computer slows down.
Exactly. So Windows is constantly juggling memory resources, trying to give each application what it needs without, running out.
Oh, wow.
It's like a very complex game of Tetris.
Wow. So it's not just as simple as having enough RAM. There's a whole lot of like behind the scenes action going on.
You got it. Windows uses a technique called virtual memory to basically make your computer think it has more RAM than it actually does.
Virtual memory, how does that work?
Okay, imagine you have this giant whiteboard, right?
Yeah.
But you only need a small section at any given time.
Okay, I can picture that.
So virtual memory is like writing on that small section and then storing the rest of the whiteboard away until you need it again.
So Windows is basically what? Swapping data between the RAM and the hard drive? Just like making sure the most important stuff is always like readily available?
Precisely. And it's a pretty remarkable feat of engineering when you think about it. It's all about balancing efficiency and performance.
This is all so much more complex than I ever realized. I'm starting to see why understanding Windows internals can be so valuable.
Absolutely. It's like having a secret decoder ring for your computer, Helps you understand why things happen the way they do. Gives you the knowledge to potentially even fix things yourself.
And who wouldn't want to be their own tech support, right? Okay, so we've talked about how Windows protects itself. It protects our applications from crashing the system. And we've gotten a taste of how it juggles those memory resources. What other mysteries are we going to unlock today?
Well, let's talk about something that's evolved drastically over the years, right? Storage. I mean, we've gone from those clunky hard drives that sounded like a jet engine taking off
Oh, I remember those days.
to these lightning-fast SSDs. They can boot up your computer in seconds.
It's amazing how far technology has come. But how do these different types of storage actually work with Windows?
At the heart of it all are file systems. Think of a file system like a library's cataloging system, but for your computer. It defines how data is organized, stored, and retrieved on your hard drive or SSD. Without a file system, it would just be a jumbled mess of, well, data.
So it's like the Dewey Decimal System for our digital world.
Exactly. And Windows uses different file systems, like NTFS and FAT32, each with its own, strengths and weaknesses. But regardless of the file system, they all work with drivers. Again, to read and write your data.
Drivers again. They really are the unsung heroes, aren't they? Connecting everything to everything else.
They are. And they're involved in one of the most fascinating aspects of modern storage, virtual hard disks. Imagine having an entire computer, operating system and all, contained within a single file on your actual computer.
Wait, like a computer within a computer?
Exactly. That's the power of virtual hard disks, or VHDs. They're incredibly versatile. Like you can create isolated environments for testing software, running older versions of Windows without affecting your main system.
That's mind-blowing. It's like having a digital time machine for your computer.
Exactly. And it all comes down to how Windows leverages these technologies to, manage and organize your data.
This is all incredibly fascinating, but I have to admit, it also makes me wonder, how does Windows even get started in the first place? Like, what happens from the moment I press the power button to seeing that familiar desktop?
The boot process. That's where things get really interesting. It's like a carefully choreographed dance with different components taking the stage at just the right moments.
I'm ready to learn the steps. So what's the first move in this dance?
It all starts with the BIOS, or UEFI. They're like the conductors of the orchestra. They're responsible for waking up the hardware and making sure everything is in working order.
So before Windows even enters the picture, the BIOS, or UEFI, is making sure the stage is set.
Exactly. They run a quick health check, making sure the CPU, the memory, the storage devices are all present and accounted for. Then they look for the boot device, which is usually your hard drive or SSD.
And that's where Windows is waiting to take the stage.
You got it. The BIOS, or UEFI, they hand off control to a special program called the bootloader, which is like the stage manager, responsible for finding and loading Windows.
So the bootloader's like, all right, Windows, you're on. What happens next?
The bootloader, it reads instructions from the boot configuration data, or BCD. And this BCD, it tells the bootloader everything it needs to know about your Windows installation, like where to find it, what boot options are available. It's essentially a blueprint for the entire boot process.
So the BCD is like the script for the play, making sure everything happens in the right order.
Precisely. Once the bootloader has the script, it cues the Windows kernel.
Yeah.
That's the heart and soul of the operating system.
The kernel. We've heard that name a few times already. It sounds like a pretty big deal.
It is. Think of the kernel as the director of the entire operation. Takes over from the bootloader, initializes itself, and starts loading all those essential drivers.
Essential drivers, like the ones for the hard drive, the display, the keyboard, right? The ones that let Windows talk to the hardware?
Exactly. Those essential drivers, they're like the stage crew making sure everything's set up and working correctly for the main performance.
Okay, so we've got the conductors, the stage manager, the director, the stage crew. Who else is involved in this production?
Well, once the kernel has set the stage, it hands things off to the session manager subsystem, or SMSS for short.
The session manager subsystem. That sounds important. What's its role in all of this?
The session manager subsystem is responsible for creating the user environment. It's like the set designer, creating the backdrop for everything that's about to happen. This includes starting the process that handles those user logins and loading the user interface. That's what we interact with on a daily basis.
So it's the session manager subsystem that's setting the stage for us, the users, to step into the spotlight.
Precisely.
Wow. This whole boot process is way more elaborate than I ever imagined.
It is. And it's all designed to happen so seamlessly that we rarely even think about it. But understanding this intricate dance, it can be incredibly valuable, especially when things go wrong.
That's a great point. If Windows isn't booting properly, knowing the steps can help you figure out where things are going haywire.
Exactly. It's like knowing how a car engine works.
Yeah.
If it breaks down, you have a better chance of figuring out why.
I like that analogy. So we've got the BIOS UEFI doing their initial checks, the bootloader finding Windows, the kernel taking charge, the session manager subsystem setting up the user environment. Are there any other key players in this boot process before we actually see the Windows login screen?
Absolutely. The session manager subsystem then kicks off two very important processes, winit.exe and CSRSS.exe. Think of winit.exe as the system's, like, diligent housekeeper, right? Making sure everything's clean and in order. It loads up essential system services, gets the network ready to go, even starts the local security authority subsystem, which handles, you guessed it, security and authentication.
Okay, so winit.exe is like the security detail, making sure everything's locked down and protected.
You got it. Now, CSRSS.exe, that one's like the maestro of the user experience. Responsible for managing the user mode side of things, where all our applications run. It creates that initial Windows, station, and desktop, making sure your applications have all the resources and the right environment they need to function properly.
So it's like CSRSS.exe is the one saying, all right, everybody, places, let's put on a show for the user.
Exactly. It's the final touch before the curtain rises, and we see that, that familiar Windows login screen.
This has been absolutely fascinating. It's amazing to think that all this happens in the blink of an eye, from the moment I press the power button to seeing that logo on screen.
It's a testament to the complexity and sophistication of modern operating systems. And you know what? We've only just scratched the surface.
For something that's supposed to just work, Windows sure throws a lot of curveballs our way.
Oh, yeah?
Speaking of which,
Blue screens of death.
you read my mind. Today we're diving into the world of crash analysis and those infamous blue screens. Honestly, they used to totally terrify me, like the computer equivalent of like a flatlining heart monitor,
Right.
But according to this excerpt, we can think of them more like cryptic messages from our system.
Exactly. They're not just random crashes. They're actually packed with information if you know how to, read them.
Okay, I'm intrigued. So how do we decipher these messages? Walk me through it.
Well, the first thing you want to look for is the stop code.
Okay.
That's that hexadecimal number, usually displayed very prominently on the blue screen.
Right.
And it's basically a category for the type of error.
So it's like a general diagnosis before we get into the specifics.
Exactly. For instance, the stop code 000000001 usually signals a driver issue.
Okay.
Like a driver trying to access a part of memory it shouldn't.
Okay, so the stop code gives us like a starting point. What else can we learn from these blue screen moments of doom?
Well, the blue screen also usually shows a few other hexadecimal numbers called parameters.
Right.
And these are like the supporting details. They help pinpoint the exact location or cause of the problem, often including memory addresses, maybe driver names or other clues.
So it's like piecing together a puzzle, using those clues to figure out what made the system trip.
Precisely. And to help us solve this puzzle, Windows actually creates something called a crash dump file.
A crash dump? That sounds intense. What exactly is in this file?
Think of a crash dump, like a snapshot of the system state right at the moment of the crash.
Okay.
It captures what programs were running, which drivers were loaded, even the contents of memory.
So it's like a digital crime scene, frozen in time, waiting for us to analyze it.
Exactly. And just like detectives have their tools, we have specialized software that helps us analyze these crash dumps.
Okay.
One of the most powerful ones is WinDib.
WinDib. That name rings a bell. Sounds a bit intimidating, to be honest.
It might sound intimidating, but it's like having this really powerful magnifying glass for your crash dump.
Okay.
With WinBig, you can examine the tiniest details, trace back the steps that led to the crash, and hopefully figure out how to prevent it from happening again.
Okay, I'm starting to see how this could be useful. So we've got the blue screen acting as an alarm.
Right.
We've got the stop code and parameters giving us clues.
Yeah.
And the crash dump, that's providing like a detailed record of the event. And then with tools like WinBig, we can actually decode all this information and like potentially solve the mystery of the crash.
Exactly. And while blue screens are never fun, they don't have to be the end of the world.
I have to admit, this is making me feel a lot more empowered. But what about those times when the system doesn't even give us the courtesy of a blue screen?
Right.
What about when it just freezes?
Ah, yes. The dreaded system hang. That's when things get a bit trickier.
Yeah.
But don't worry, we're not completely powerless.
Okay.
Good.
Because those silent freezes always feel way more ominous to me. Like, is it even going to come back?
I know what you mean. So the first thing to do when you're faced with a system hang is try to figure out, is it actually completely frozen or is it just running extremely slow?
Good point. Because sometimes it's hard to tell the difference. How can we be sure?
Well, if you can still move your mouse cursor or you see that hard drive light flickering, there's a chance your system might just be overloaded.
Okay.
But if everything is completely unresponsive no matter what you do, that's a true hang.
Okay, so let's say it's a true hang. What's our next move?
If possible, try to source a crash dump.
Okay.
Even though there's no blue screen, you can sometimes trigger one by holding down the power button until the system reboots.
So it's like we're saying, all right, enough of this, time for a hard reset, and hopefully some answers.
Exactly. And once you have that crash dump, you can actually analyze it, just like we would with the blue screen crash dump.
Okay.
Looking for those clues about what was happening at the time of the hang.
Makes sense. But what if, for some reason, we can't capture a crash dump? Or what if the crash dump doesn't give us any, clear answers? Are we just out of luck?
Not at all. We have a few more tricks up our sleeves.
Okay, good.
In those cases, we can use something called a kernel debugger, like WinDebug again,
Okay.
to actually connect to the frozen system.
Wait, you're saying we can, connect to a frozen system and poke around inside? How is that even possible?
It's like a backdoor into your system. With the right configuration, you can actually connect to the frozen system from another computer using a special cable or even just a network connection. It's like having a remote control even when the system itself is unresponsive.
That's incredible. So we can essentially, remote control a frozen computer to see what's going on under the hood.
Exactly. And by carefully examining the system state this way, we can often pinpoint the culprit behind the hang.
This is all starting to make me feel a lot less intimidated by those mysterious system crashes. It's empowering to know that there are tools and techniques to help us, get to the bottom of things. But before we move on, there's one more crash-related scenario I'm curious about. Virtual machines. We talked about those earlier, how they're like computers within computers.
Right.
What happens if a virtual machine crashes?
That's a great question. And it's becoming increasingly relevant, as more and more people are using virtual machines for work, personal projects.
Yeah.
The good news is that the same principles of crash analysis still apply, but with a slight twist.
A twist? What do you mean?
Well, since a virtual machine is essentially a software representation of a computer running on top of your actual operating system, we kind of have to account for that extra layer, right?
So it's like having a crash within a crash.
In a way, yes. But don't worry, most virtualization platforms like Hyper-V, they come with special tools designed to help us debug crashes within virtual machines.
So we're not flying blind.
Not at all. These tools can often capture crash dumps, even if the virtual machine is totally frozen. It's like having a safety net for your virtual world.
That's reassuring. It sounds like we've got a whole arsenal of tools and techniques at our disposal to tackle those frustrating moments when Windows decides to throw a tantrum.
Exactly. And you know what they say? Knowledge is power. The more you understand about how things work, the less intimidating those oh no moments become. All right, we're back for the final part of our deep dive into Windows internals.
Yeah.
And I have to admit, I've been, both excited and a little nervous about this next topic.
Let me guess. The Windows registry.
You got it. It's always seemed like this mysterious, kind of scary part of the system to me. Like one wrong move in there and you could really mess things up.
I get it. The registry definitely has a bit of a reputation.
Yeah.
But think of it this way. What's the one thing that all good detectives need?
Clues.
Exactly. And that's what the registry is. It's this massive storehouse of clues about your Windows system.
It's a database, really. And it holds settings, configurations, options for almost everything. Your hardware, your software, your user preferences, you name it.
Okay, so instead of a scary labyrinth, maybe it's more like a giant library.
That's a much better way to think about it. Instead of dusty books, it's got keys, subkeys, and values.
Okay, break that down for me. What are keys and subkeys again?
Imagine a filing cabinet.
Okay.
The keys are like the main drawers.
Okay.
The subkeys are like the folders within those drawers.
Right.
And the values are the actual files inside those folders.
Gotcha.
Containing the settings themselves.
Okay, that makes more sense. So if I want to change, my desktop background, that setting is stored in a specific value somewhere in the registry.
You got it. And every time you install a program, it often adds its own entries to the registry. Tells Windows where to find its files, what settings to use, all kinds of useful information.
So it's like a constantly updated record of how Windows is configured.
Exactly. And while it's true, you shouldn't go poking around in there without knowing what you're doing.
Right.
The registry can actually be incredibly useful for troubleshooting.
Okay, now you've got me curious. How so?
Well, let's say a program isn't working correctly.
Right.
By examining its entries in the registry, we might be able to figure out if a setting got corrupted, or if there's maybe a conflict with another program.
So it's like detective work, using the registry to trace back the steps that led to the problem.
Precisely.
Yeah.
And if you need to make changes, Windows has a built-in tool called the Registry Editor, or Regedit.
Regedit. Oh, yeah, I've definitely seen that name before. usually in warnings that say, don't touch this unless you know what you're doing.
And those warnings are there for a good reason. Changing the wrong value in the registry can have, well, unintended consequences.
Yeah, I bet.
That's why it's crucial to back up the registry before making any changes, just in case.
Consider it backed up. But even with the safety net, it sounds like navigating the registry requires a certain level of, caution.
Absolutely. It's like working with, a delicate machine. You need to know what you're doing, take things slowly. But with a bit of knowledge and the right tools, even the registry can become less of a black box and more of a valuable resource.
This has been an incredible journey. We've gone from the most fundamental concepts of how Windows is structured to understanding how to troubleshoot crashes to even decoding the mysteries of the registry.
It really is amazing what you can learn when you start, digging beneath the surface.
Absolutely. I feel like I've gained a whole new appreciation for the complexity of the system that we use every single day and a newfound confidence in my own ability to understand it and even manage it.
And that's really the goal, isn't it? To empower ourselves with the knowledge to make informed decisions, solve problems.
Couldn't have said it better myself. So to all our listeners out there, if you've ever felt intimidated by the inner workings of your computer, just remember, it's all just code. And with a little curiosity and the right guidance, anyone can unlock the secrets of Windows internals.
And who knows, you might even enjoy the journey.
Thanks for joining us on this deep dive into Windows internals. Until next time, happy exploring.